Hello, everyone. So we have number 24 from 10A, and I think this was 23 on the 12A as well. So we call a positive integer fair if no digit is used more than once. Okay, so that is important. So we cannot use anything more than once, as has no zeros, and no digit is adjacent to the two greater digits. So and examples are given for the fair and unfair numbers. How many fair positive integers are there? So whenever we have some problem like this, I really ask students to really understand the given example because these are usually the good one to explore what they are asking for. So we are told the 196 is good. So let's see why. Because they are all different, right? That's good. No zeros, that's good. And then it says no digit is adjacent to the two greater digits. So like when you look at, let's say, 9, the left is 1, the right is 6. Those are smaller than 9. So 9 is not adjacent to larger numbers, which is good. And then 2 and 3, there is only two-digit numbers, right? And then 3 is larger than 2, or 2 is next to a larger number, but it's only one side. So which is why if there is like 4 right here, then this was not going to be a fair, but in this case it is. And in this case, this is also fair because 2 is larger than 1. That's good, but it's smaller than 4, so 2 is not next to two larger numbers. So, and then 4 is larger than 2, but less than 6, which is good. And then it is fair. And then these are not the fair. Like, let's see why. The 4 is next to 5 and 6. So since it's kind of 4 is smaller than two numbers next to it, that's not a fair. And then 0 is used, that's why it's not fair. In this case, 3 is used twice, so that's why it's not fair. So like the idea I believe in this problem is like when you look at all these numbers, somehow there is actually increasing or decreasing pattern. Like in this phrase example, 196, you got 1 and then 9, you increase and then you decrease after. And then 2 and 3, you just increase 2 to 3. And then 1, 2, 4, 6, you increase all the way to the 6 and then decrease after. So you are gonna have a like a integer that is increasing, going up, and then going down at some point. So you may just have a mountain, and then you can go down after it. So you don't have to go down. So you can just increase and stop there. So which is this case, but at least this is legal. So that is good. But if I have something like increasing, decreasing, and increasing again, that is no good. So for example, like we have right here, so that is not good. So that's kind of what we really want to see what's going on. So after this one, maybe we can try make in general. Like if you don't really see how that looks like, you can kind of start with, let's say, some small cases and then list a few things just to see how that looks like. But I will say we can make this in general without really listing. If you are not like getting that, so you can always list and see the pattern at some point. But at least we are looking for a peak number. So that means we have 9 options for the peak number, right? So we can just try to choose the mountain number at the top, and based on that we can choose the other numbers around that. So like the first choice, we have the first step, I will choose a, peak number, pick the larger number, right? So the peak, so we have like 1, 2, 3 all the way to the 9. So we have 9 options for them. But the second, I will choose a smaller number. So like my second number, let's say I will just choose, let's say some number D. Let's say this is the elements of anything like 1, 2, 3, all the way to the, if I choose my first number like 1 through 9, which I don't know the number, but let's say this is m minus 1. So like what is m? M is the number that you choose on the first step. So let's say you choose 3. That means your D, the second number you're choosing could be only 1 and 2. Okay, that is the option. If you choose like first number as 9, then you can choose 1 through 8. So you have that many options. This third step, I can just say, like as soon as I choose one of these numbers, but how many options do I have? M minus 1 option. As soon as I have this one, I can make my kind of selection. Like for example, if I choose, let's say 2 as my first number, then I do have only one option. That's 1. So, but this one, I can choose it if I want to, and then put it somewhere around this 2. So I can just make it 1 and 2 or 2 and 1. But also I can actually not choose 1 at all. So that means I can just get 2, and then these 3 are all valid. But if you don't get it, let's say I choose, let's say 4 as my pick number, and then I have now 1 through 3. So I can choose nothing. So that means this is going to be number that is fair. If I choose, let's say 3, so I can just write it to the left, or I can write that to the right, right? So that is going to be 3 option. If I want to go with 4 again, if I want to choose 1, and then I can go with like 4, 1, or I can just don't choose that one at all. So I have 3 options, which means every choice I have from the first selection, which I have 9 options, right? And then I can choose the one of the options that is available from the second selection. So that is n-1 option. And then for the third one, we do have actually 3 ways to finish the rest. So we have like either do not use it, do not use the deed that you choose, or just put it on the left, or put it in the right side of the number that you selected from the first selection. So with that in mind, the question becomes this. So if you do kind of write this as the sum notation, so I will say this is my sum, and then my sum start with 1 because I can choose 1 as well from the first selection, and then I can go all the way to the 9. And then every time I choose one number, I have like one lesser number of option to choose to get some numbers around. So in that case, we have n-1 options, right? But every time we choose a number from this list, we have 3 ways to distribute. So which means we have 3 to the n-1 ways we can do this. So I hope that's clear. So if it does not really make sense, so you may try choosing, let's say, like smaller values of m, let's say 1 and 2 or 3, and kind of look at the options. And this is what we are interested. So that's basically, if I choose this as 1, so you get 3 to the 1 minus 1, which is 0, which is 0 plus 3 to the 1, 3 to the 2, all the way till 3 to the n-1 is like 3 to the 8th power. And then this is a geometric series, so I can just say a over 1 minus r. I can use that, but the r is not lesser than 1, so which is why we cannot use that. But if you do remember the geometry series formula, you can just apply it because that will be easier. But if you don't know, so I'm going to say, let's say this is s is equal to 3 to the 0 plus 3 to the first, 3 to the second, all the way till 3 to the 8th. And then I'm going to multiply this by 3 because that's the common ratio. So you will get 3 to the first, 3 to the second, 3 to the third power, all the way to the 9th power. And then we just subtract this. This is actually the way that we use to get the formula itself. So I just did it one more time. If I don't remember the formula, which I do, but I don't like using that much. So 3 minus 2 is like 2s. And then that will be 3 to the 9. And then you got minus 1. And then divide by 2. So you got 3 to the 9 minus 1 over 2. And at this point, just calculate this value. You can remember some of the power of 3's, and you can just even use the difference of the cubes if you want to, because that will cancel that too. So, but just do whatever you want, and then that will give us 9841. So this was an interesting question, to be honest. I hope that was clear. I'll see you in the next video.